All right, so we're here doing group meeting 17 for chapter 17. Fairly easy stuff, going back over what we went over on Tuesday, and then just that T-score, not very difficult. So starting off with number 3, something simple right off the homework, or right off the wiki. It just asks which symbol is for the true population portion, and that's going to be the regular P with no symbol.
And for number 4, we got they're asking for the requirements for conducting a confidence interval, and if it satisfies, and the answer is true for that.
True, perfect. And the next one asks if the requirements for conducting a hypothesis test are satisfied, and it is because it's got that the high population of 100 and has all the things required for that. So that was true.
And then maybe you can go for number 7 and 6 and 7 because you got it right. You can explain it. I'll do 8 and 9.
So 6 and 7. So all you need to do is to find that P. I forget what it's called. Is all you have to do is you take so the formula is fairly simple. It's a basic ratio. So the formula is x over the n is going to equal that p, which makes it 0.75. So this is going to be your formula right here, this one right here. So you should enter it in. So your x is going to be that 45, and the n is going to be the population of 60, which is 0.75. Did you get that?
I got a different one, but I got 0.347. But yeah.
How did you get 0.437?
It's just because in calculation I did it different, so that's what I got it wrong.
Okay. So then so then when you go on and want to find the confidence interval, the true portion for first degree murder of the first degree murder trials, like we were seeing, this one's also fairly simple. You're just finding that let's see, I have that formula here somewhere. I got it right here. I'll pull it up right here on the wiki. Oops, wrong. Not the one I wanted to open. Here we go. Now I opened the email again. I want I learn. So this one was just was the ones that we've done before with finding the upper and lower intervals, where you find it through you find that initial P for this situation, and then you're going to multiply the. Let me see. Let me pull up the wiki real quick. I had it pulled up and then it exited out on me. So this one is going to be this formula right here is P plus or minus. Yeah, you would have gotten this question wrong if you would have missed this one and the one. If you missed the one before, you would have missed this one as well. And then you do P. Oh, I actually may have gotten this one wrong as well because I didn't. No. Wait. Let me go see through here. I said. Okay. I think I misread this, and I would have gotten. I need to change this up a little. So let's see. Where did I see this formula? So I must have missed that. So then, what it's gonna be is. So the formulas we were working with on. Divided by n. So it's gonna be this formula right here. You see that?
Yep.
So it's going to be that formula right in there. So you're going to enter that 0.75 plus and minus. Oh, excuse me, I missed one. Sorry. So it's going to be plus or minus the z. All right, excuse me. This is going to be the formula. Sorry, I missed that z in there. So it's going to be that. So you're going to enter that in, which it was for 95% confidence interval, right? So that Z is 1.96, and then you multiply that, and then you do the P, which was 0.75. 1 minus 0.75 divided by, which the N was 60. So the actual formula for this one, for this study is going to be this right here. This is what you're going to need. So then when you put that in, I do this kind of rough, times 0.25. No, I actually think I did this one right. Divided by 60, the square root of that. All right, and then multiplied by that Z, and then plus or minus, so 0.75 plus that 85. Nope, I got these ones right. I did put this one in right. But yeah, so those answers, when you plug this in, and it's fairly simple. You just put it through, and you'll get that 0.64, and then 0.68 are your upper and lower bounds on that. And then if you do for number 8 as well, this one's actually fairly simple. Something we've been looking at for quite a few weeks now. Is if the sample size becomes bigger, that what is it called? The width is going to actually decrease there.
And then for number 9, we got to conduct a hypothesis test for a one proportion. And to require, suppose, like 1/2, the smaller n can be, and the both requirements still be met. And it's in this case, it will be 20. And for the other one, it will be 100 for number 10.
Perfect. All right. And then the next one, we're talking about this study that we have here about the macroinvertebrate invertebrate. Excuse me, the macroinvertebrate invertebrate for the water quantity study and the reading. About 60% of macro invertebrate water quality indicators have historically been associated with good health. Researchers suspect that the water quality in the area has decreased. Conduct a hypothesis test using a significance of 0.05 with the following hypothesis. Null hypothesis P equals 0.6, and the the alternative hypothesis is P is less than 0.6. So then it says they collect new data, and this time N equals 80 and X is 38, indicate good health. And then as if the conditions in conducting the hypothesis test are satisfied, and it's yes, you have a large enough sample, and then it gives you the null and alternative hypotheses, and it gives you those the sample from inside of the population. And so 11 is true.
Perfect. And then it's looking for the p-value, and then for the p-value, and then the answer for that is going to be 0.475.
Yeah, perfect. Exactly what I got.
And for the test statistic, or for C, it would be. I'm just saying this because maybe you can explain the next one, because I got it wrong, the p-value, because as we talked before, is in the applet. I put it right, the left side. So for number 13, the answer is minus 2.282.
Yeah, that's what I got. Let me go ahead. So that z-score, not very difficult. Going back to finding the standard deviation, and then between the p-value, or then taking the value and subtracting that from the mean. Let me go ahead and just take this down real quick to explain. So to explain the answer we just got for that negative 2.282, it's going to be the p minus p over standard deviation, which we go back to the this one right here, 1 minus p over n equals z-score. So this is our z-score. Where are we at? This is our z-score formula right here. Not too difficult. You just got to plug in the numbers, and once you do get that, that's gonna once you get that p, which is the 0.475, and then when you put that together in here with the sample size and everything and find the standard deviation, you get that negative 2.282. So then we're going to talk about what you need to do with number 14, which looks like kind of some questions there, but nothing too difficult. We're trying to find out if the alternative hypothesis is asking to see if p is less than 6. So then what we're going to have to do there is on the applet, you're going to have to shade that actually to the left instead of to the right, because we're trying to find everything that's greater than that and what the opportunity there is. So with that, I got 0.989, which will fail your null hypothesis for 15, because we're going back to that significance level of 0.5, which is definitely a lot greater than that. So we failed to reject the null hypothesis. Let's see.
No, you reject the null hypothesis.
Excuse me. Yeah, sorry. You reject the null hypothesis because it is greater than that 0.6. Excuse me. Sorry. And then this last for 16. So you probably have to change my answer there. What did you get for that one on 16?
Then, for that reason, there is sufficient evidence to conclude that the water qualities in the area has decreased.
Has decreased.
Yeah.
So there is sufficient.
There is sufficient. Yeah.
So number or the first answer.
Yep.
All right. Perfect. Yeah. So I don't know if you understood that on the applet, because you had to have shaded it that other direction. All right, sounds good. All right, and then we plan to meet tomorrow at 2 o'clock to go ahead and finish up to design our study and how we want to do that, and see what we can do there. But I think we're pretty solid and got this ready to go for next week.
Okay, perfect.
Talk to you later.
Okay, see ya. Bye.